Okay, so today we're going to do Unit 4, Day 6 notes, which is finding the leg and applying the converse of the Pythagorean theorem. So let's just quickly review what we talked about yesterday. So we have a right triangle, and a right triangle has a 90-degree angle, which is identified by the little square. Now, across from the 90-degree angle is your hypotenuse, and that's known as the letter C. And then on the other two sides, we have the legs, which are known as either A or B, which are interchangeable. And the theorem itself is A squared plus B squared equals C squared. Okay? So now, let's go ahead and go to the example. So example 1 is the same directions, which is finding the missing side and to round to the 2 decimal place. So now, first thing I need to do is I need to identify which of these is the letter C. Now remember, the letter C is always across from the 90-degree angle. So there's my 90-degree angle. If I go across from it, that will be my letter C. That means the other two sides are going to be A or B. It doesn't matter which one you choose as A and which one you choose as B, because if you work it out correctly, you will get the right answer. The side that matters is the hypotenuse, which is the letter C. That's the one that you need to pick out correctly. If you pick the wrong number for the letter C, then your answer is going to be wrong. So just make sure that you start off by identifying which one's the correct C, and then A and B can be either or. So I'm going to say that A is 3.7 and B is the letter X, which is the one we're looking for. Now, let's go ahead and plug it into my theorem. A squared plus B squared equals C squared. So A squared is 3.7 squared plus B, which is just going to say as B squared, equals C squared, which is 4.2 squared. Now, the first thing I want to do is square my numbers. So 3.7 squared using your calculator will give you 13.69 plus B squared stays the same because you can't do anything to it, equals 4.2 squared. So go ahead and square that number and you get 17.64. Okay? Now, as you can tell, this is going to be a two-step equation. The first thing you want to do is you want to jailbreak the 13.64 to the other side because you're solving for the letter B. We want to know what the letter B is, so that means I have to move everything away from B. So the opposite of a positive 13.69 will be a minus 13.69. So this is gone, and I'm left with B squared equals 17.64 minus 13.69. And I end up with 3.95. Now, the opposite of a square, because I have to get rid of the square, it will be a square root. So when I square the square, or when I square root a square, they cancel each other out. So I'm just left with the letter B. So now I have to do the square root of 3.95, and I end up with 1.99. Okay. Now, my directions told me to round to 2 decimal places, but if you really wanted to, you can round this to the number 2 because it's really, really close. It's like right there. It's basically 2. So in this situation, it will be okay to round to 2, but if the directions state round to the 2 decimal places, and it's not close to a whole number, I would just leave it as it is, okay? Now, let's move on to number 2. Now, number 2, same thing. First thing I need to do is identify my letter C. Well, the letter C, or the hypotenuse, is across from the 90-degree angle. So across from the 90-degree angle is my letter C. That means the other two can be either A or B. For this one, I'm going to say A is X and B is 5.3. Okay? Or you could have done it the other way. You could have said 5.3 is A and X is B. Either way, you should still get the same answer. So now, let's plug in our theorem. A squared plus B squared equals C squared. Now, A is just itself. B is going to be 5.3 squared equals C squared, which is 6.9 squared. Now I want to take care of the squares. Obviously, A squared stays the same. Now I want to do 5.3 squared gives you 28.09. And then I'm going to do 6.9 squared, and that gives you 47.61. Now, I'm solving for A, so that means I have to jailbreak the plus 28.9 to the other side to become a minus 28.09. So this is gone, and I'm left with A squared equals 47.61 minus 28.09. And I'm left with 19.52. Now, to get rid of the square, I have to square root because that's the opposite. So these cancel out, and I'm left with A equals. Now I'm going to use my calculator to do the second square root of 19.52, and I end up with 4.42 because the 8 changes the 1 into a 2. So I'm left with 4.42. And there's my answer. There's my side. It's one of the legs, obviously, okay? Now, let's move on to number 4. Now, first thing I would like to do is identify what my letter C is. The letter C is across from the 90-degree angle, which is right here, 22. That means the other two sides will be A and B. So using my theorem, A squared plus B squared equals C squared. Now, A will be 17, don't forget your square, plus B squared, because that's what we're looking for, equals 22 squared. Now, using my calculator, I'm going to say 17 squared, which is 289. Bring down your plus, B squared equals, and then 22 squared will give you 484. Now, I'm solving for B, so I need to jailbreak the 289 to the other side. So that becomes a minus 289. So B squared equals, now 484 minus 289 will come out to be 195. Now the opposite of a square is the square root. And the square and the square root cancel each other out. So I'm left with the letter B equals the square root of 195 will come out to be 13.96. And the reason that it stays as a 96 is because the 4 does not have the power to change the 6 to a 7, so it just stays the same. Now, if this 4 was a 5, a 6, a 7, an 8, or a 9, then it would have had the power to change the 6 to a 7, but it doesn't, okay? So it just stays as 13.96. Okay, let's go ahead and flip to the other side. Now, at the very top, we have two examples where you're given the measurements A, B, C, and as you can tell, the letter B is what's missing. These are just like the problems we did on the other side. The only difference is that we don't have to look for the measurements, or we don't have to identify which one's A, which one's B, or which one's C. That information is given to us. So if you want to work those problems out, you can go ahead and work them out, and then you can ask me in class the next day to see if you got them correct. But we're going to move on to the next section, which is the converse of the theorem. Now, the converse basically allows us to use the Pythagorean theorem and determine if three measurements are a right triangle. So let's go ahead and jump into example 1 to see what I'm talking about. Now, the question states, do the following lengths 3 feet, 4 feet, and 5 feet form a right triangle? Well, I'm going to take those three measurements and plug them into my theorem. But before I can do that, I need to identify which one's A, which one's B, and which one's C. So just like before, I'm going to start off by identifying my letter C. Now, the letter C is the measurement that represents the hypotenuse. And we know that the hypotenuse is the largest side. So looking at these three measurements, I need to identify which one's the largest. And obviously 5 is the largest. So that means that's my hypotenuse. So that means that's my letter C. With that being said, the other two sides are my legs. Now, if you remember, it doesn't matter which one you choose as your A and which one you choose as your B. So just to keep the flow of the letters, I'm just going to say this is A and this is B. So it will look like ABC. So now, using my theorem, A squared plus B squared equals C squared, I'm going to plug in my letters. I'm going to plug in my numbers in the place of the letters. So 3 squared plus 4 squared equals 5 squared. Now, I'm going to solve and simplify each side and then see if I get a true statement. If I get a true statement, then it's a right triangle. If I get a false statement, then it's not a right triangle. So let's start with this side. 3 squared plus 4 squared. So I'm going to let my calculator do the hard work. 3 squared plus 4 squared gives me 25. Now let's see what about the other side. 5 squared gives me 25. So as you can tell, this is a true statement. So this is a right triangle. Now let's do example 2. Do the following lengths 12, 15, and 18 form a right triangle? So once again, I'm going to identify which one's A, which one's B, and which one's C. Well, as you can tell, 18 is C because that's the largest side. So I'm going to say the other two sides are A and B. So we're going to have 12 squared plus 15 squared equals 18 squared. Now, if I do 12 squared plus 15 squared, I end up with 369. If I do 18 squared, I end up with 324. And as you can tell, this is not a true statement, so it's not a right triangle. Okay? Now, example 1 and 2 are the type of problems you're going to see on IXL, but the types of problems you might see on the EOG or the benchmark or on SchoolNet will be like number 3. So they might ask you, which of the following forms a right triangle? So I need to identify which of my answer choices is the right triangle. So in other words, I'm looking for the one that gives me a true statement. So let's start with answer choice A. Obviously, my largest side is 1.5, so that's going to be C. The other two sides are going to be A and B. So if I do my theorem, A squared plus B squared equals C squared, I'm going to do 0.9 squared plus 0.6 squared equals 1.5 squared. Now, let's take care of the left side. 0.9 squared plus 0.6 squared gives me 1.17. Now the other side is 1.5 squared gives me 2.25. Obviously, this is not a true statement, so my answer is not A. Moving on to B. C is 1.5 again, and A and B are the other two measurements. So that means I'm going to do 0.9 squared plus 1.2 squared equals 1.5 squared. Well, we already know that 1.5 squared is 2.25. Now let's figure out what the other side is. So 0.9 squared plus 1.2 squared gives me 2.25. And as you can tell, this is a true statement because it's the same number. So my answer is B, because that's the one that forms a right triangle. Now, if you have any further questions about today's lesson, please do not hesitate to ask me in class the next day, okay?